The Bambu Lab H2D isn't just a 3D printer, it's a lot more than that. With game-changing features, this creative powerhouse could shake up not just 3D printing, but the entire digital fabrication industry. Let's dive in and see if it lives up to the hype. This video is sponsored by PCBWay. Bambu Lab's tagline for the H2D is "Rethink Personal Manufacturing," and what they've produced does attempt to do just that. This machine is designed to offer creators, makers and small businesses a versatile solution for all their fabrication needs. Not only is the H2D a cutting-edge 3D printer, but it can also laser cut and engrave, blade cut things like vinyl and sheet materials, and also act as a pen plotter to draw anything you can imagine. In this video, I'll be quickly running through all of the things that Bambu Lab claim the H2D can do, along with telling you what they've done with their latest release to make it all possible. First off, as of the 25th of March, the H2D is available to buy worldwide in a couple of different guises. The combo version, which is the 3D printer with Bambu Lab's new AMS2 Pro, but without the laser and other accessories, is in stock, ready to ship everywhere but the UK, which will have to wait 2 weeks. The full laser version with all of the bells and whistles is available for pre-order with delivery in 2 weeks from the 25th, and the H2D on its own without the AMS will be available soon. So we've all been waiting long enough. What are the headlines? The H2D is pretty big, but it's not quite as big as some of you were hoping. The build volume is technically 350 by 320 by 325 millimeters, but how much of that you can use will depend on what you want to do with it, which I'll get to soon. The H2D also has 2 hot ends in a single print head. These hot ends can be used to print with different filaments without the need to purge each time you swap, and each one can be fed by either a single externally mounted spool or multiple AMS units, which can be combined to give you the possibility of printing with an incredible 24 different filaments in one single print. As I already said, there is the option of clipping on a laser module to turn the H2D into a fully functional laser cutter and engraver. I know many of you will be surprised to see a laser on a 3D printer, and it's something I'm yet to be convinced about myself, but the good thing is that there is both a H2D without a laser and one with. You can just buy the features you want or even upgrade later if you're not sure what you're going to need. To get rid of the inevitable fumes produced from using a laser, the H2D uses a powerful extraction system with 3 layers of filtration and a fresh air inlet. The laser module can be swapped out with a blade cutter that can cut sheet materials and a pen holder that can turn your H2D into a pen plotter too. I must say here that you won't be seeing a load of shots of the H2D doing all of these things that I'm talking about, as this one has literally just arrived, and I've held off starting my testing program to bring you this video. Also, it may be a little early, but if you do want to buy one, then there are links in the description where you can find the best deals. And whilst Bambu Lab did send this machine to me, I'm under no obligation to say anything, and they don't see this video before it goes out. In fact, they don't even know I'm making this video. I will, of course, produce a full review video once I've fully tested the H2D, so hit subscribe if you want to see that when it's done. So now we know the basics of what the H2D can do, but how it does all of these things is just as impressive. Firstly, let's look at its 3D printing capabilities, as despite the headline added features, this is actually where I think the most progress has been made. The H2D is far from an X1C with a laser module strapped on. The whole printer has been designed from the ground up to meet the new challenges it's set for itself. The dual hot end setup is pretty clever, with the right unit acting like a conventional hot end, and the left hot end moving down when it needs to be used and then retracting up again to get out of the way. There's a clever flow blocker that basically caps the hot end that's not in use to prevent any oozing, and both hot ends are driven by a single permanent magnet brushless servo motor. With the clever use of cams and reversing of the extruder motor, each hot end can be driven independently. This also means that each hot end can run at a different temperature, making it very easy to print with 2 very different materials, using one for supports that will break away, leaving a clean lower surface to your print. If one hot end isn't going to be used for 30 seconds or more, it can also be cooled to save energy and then preheated for when it's needed. The 2 hot ends are identical A1 style units that require no wiring to be unplugged when being replaced, so nozzle swaps are simple. There's also a clever mechanism that ensures that the left hot end gets the cooling it needs when it's in use, but not when it's stowed away. As you would expect, to facilitate filament switching, there are independent filament cutters for each hot end, but the activation mechanisms now retract out of the way when not needed, so you don't have to sacrifice print area on your bed. The extruder motor itself has been upgraded to a servo motor that gives feedback rather than a stepper motor. This means that the motor itself can sense torque changes to help supply information about how the filament is extruding, if there's any slippage, and sense clogs. The precise control of the extruder torque can also reduce extrusion flaws, producing better print surface quality. Now, whilst the H2D is bringing some great innovations to personal manufacturing, we are still away from being able to complete some of the more advanced manufacturing tasks at home. The good news is that our video sponsor, PCBWay, have all the additional manufacturing capabilities you're likely to need, no matter what your project requires. When it comes to 3D printing, PCBWay have FDM, SLA and SLS capabilities, so no project is beyond them, even when you need parts printed from metal. Check out their full capabilities at PCBWay.com and receive $5 off your first order. Improved control is a theme that continues throughout the H2D with the use of not one, not two, but 3 cameras, and a 4th if you use the laser. These cameras, used in conjunction with various codes around the printer and across different accessories, ensure that the H2D won't let you do the wrong thing at the wrong time. There's a nozzle camera, print head camera, as well as a general enclosure camera, and all of them are 1080p and capable of running up to 30 frames per second. AI is used to monitor all of the camera feeds to look for errors like filament clumping, air printing, and spaghetti from a print failure. All of the AI features, as well as flow calibration, vibration compensation, and external network connections, are handled by the H2D's mainboard that features a quad-core CPU. There's also a separate motion control board with a dual M4 core MCU and a single core M7 MCU, and stepper drivers to take care of all the X, Y, and Z or Z movement, along with temperature controls, chamber status detection, and air circulation. There's also a lot going on here, as additional safety features like a door sensor are needed when using the laser to ensure potentially harmful light can't escape. The laser H2D is easy to identify, as it also has light blocking green side panels, and/or for the same reason. There is a lot of control over the print environment with this machine too. We now have not only active chamber heating up to 65 degrees, but chamber cooling too. There are inlet and extractor vents that are automatically opened and closed when needed, and an air circulation system to carefully control the print chamber environment. All extracted air passes through those 3 layers of filtration material that include HEPA and activated carbon to remove as much nastiness as possible before venting. This means that there's no more need to leave the door or lid open when printing with PLA, and you can start a print remotely using any filament you have loaded in the AMS. The H2D combo comes with Bambu Lab's new AMS2 Pro, which, like its predecessor, has spaces for 4 filament spools and has the ability to read the RFID information from Bambu Lab filament. The AMS2, however, is now also a filament dryer, and a good one at that. The problem with most filament dryers is that they're just boxes with heaters. It's all very well removing moisture with heat, but if you don't then vent this moisture, then it's going to return to the filament as soon as the heat goes. If you solve this problem with a vent, then you have the alternative problem of new moist air entering the box and getting to your nice dry filament. The AMS2 solves both of these problems by heating and circulating the internal air whilst using electromechanically controlled vents to release moist warm air when needed. Once the filament is dry, those vents close, keeping it safely stored away from humidity. An internal humidity sensor manages this process with real-time readings displayed on the printer's screen. The new AMS features don't stop there either. Likely taking inspiration from some other designs, any unloaded filament is rotated periodically to ensure even drying around the whole spool. As I said earlier, you can use up to 4 different AMS2 Pro units with the H2D, but there's also now the AMS HT, which stands for high temperature. The 4-bay AMS2 can reach 65 degrees, but the HT can reach up to 85 degrees for drying those higher temperature filaments. The HT only accepts a single roll of filament, but using an adapter, you can add up to 8 AMS HTs to your 4 AMS2 Pros to give yourself 24 different filaments to select from if you so desire. It would get quite confusing trying to keep track of all these different filament options, but the H2D can handle it with a simple process that identifies which AMS is connected to which hot end by simply pushing some filament through and seeing which runout sensor is triggered. Unfortunately, the AMS2 still can't be used for any filament that you can't reliably push down a long tube, which means that flexibles either need to be mounted separately or you can use a bypass system in all of the AMS units. And despite the ceramic filament inlets, Bambu Lab also advised that any filaments with fibres shouldn't be used with the AMS. The many different filament combinations are also handled by the Bambu Studio slicing software, which is being upgraded to allow for the multiple hot ends and AMS possibilities. When you slice a print, the software will advise the best location for each filament to minimise waste and save time. When used with the H2D, Bambu Studio will also feature an auto circles holes contour compensation option, which uses preset data for different filaments to try and make internal bores actually meet the desired dimensions. Bambu Lab also claims that the H2D can meet an incredible tolerance of 50 microns on 3D prints by not using high-cost precision components, but by using an algorithm to work out where any inaccuracies lie, and then it compensates accordingly. This is all done by using a special bed surface that Bambu Lab are calling a vision encoder, which will likely be an optional extra that many won't need. Only testing will prove how well all of this works, but if true, 50 microns is an incredible tolerance for an FDM print. While we're talking about the H2D's motion system, the tension on the belts that control the X and Y movement of the print head are monitored by the H2D's belt tension monitor, and it provides feedback if it needs adjusting for optimal performance. All of this tight control allows the tool head to move at up to 1000 millimeters per second, not that you'll be printing at that speed. Printing speeds will be dictated by what the filament you're using is capable of, but each standard hot end is capable of a 40 millimeters cubed per second flow rate with ABS, and high flow hot ends can achieve 60 millimeters cubed per second. When it comes to the filaments that the H2D can print with, the list is far too long to read out. The hot ends can reach 350 degrees, the bed can reach 120 degrees, and the chamber can heat to 65 degrees. That means that you can use the H2D to print with anything from PLA to things like PPS and PPA, and of course, everything in between. Now, one thing that's caused some controversy lately is Bambu Lab's firmware decisions. The H2D, whilst continuing with Bambu's lockdown ethos, does also allow different modes for those that want to use third-party products and software. From launch, the H2D will have 4 privacy modes. There will be the full cloud mode that will connect your printer to Bambu's cloud services and allow remote control via their Bambu Handy app, as well as watching camera feeds and receiving phone notifications on things like print status. There'll be a LAN mode which will allow local network connection but no internet access. There'll be a developer mode which will open the MQTT port for third-party control, and then an offline mode which takes you back to 2019 with no networking and files moved with a USB stick. Whether these different modes will give you what you want will depend, but I think it's encouraging that Bambu Lab recognise that there are users who don't want their printer locked into the Bambu Lab system, and they're offering alternative options. Now, earlier I mentioned that the bed dimensions are not as simple as being a straight 350 by 320 millimeters. Because the two hot ends are next to each other, the right one can't reach all the way to the left and the left one can't reach all the way to the right. Each hot end therefore can use an area of 325 by 320. That obviously overlaps in the middle. If you want both nozzles to reach all areas of the bed, then you effectively have a print area of 300 by 320. The maximum height each nozzle can print is also slightly different, as the left hot end moves down lower than the right to print. There's only 5mm difference though, with both reaching at least 320 millimeters. So what about the H2D's laser capabilities? The H2D will be available with 2 laser options, a 10 watt at launch and then a 40 watt will be available in the near future. From my experience of using my laser engravers, 40 watt is plenty of power for a home diode laser, but 10 watt is still capable of cutting softwoods, but it will likely take multiple passes for anything thicker than about 3mm. If you want to use the laser module, then you'll need to replace all of the clear panels with laser-safe green ones, which of course will be part of any upgrade kit or already fitted to units supplied with a laser module. You can see what's going on inside the enclosure by watching one of the camera feeds on the screen, which is a nice idea that I haven't seen before. There are lots of other safety features with the laser version too. There are 5 flame sensors which will shut everything down and close all vents if any kind of flame is detected. There's also a big red emergency stop button that you have to plug in and a safety key that has to be plugged in for the machine to even work. Even with all of these safety features though, any laser engraver has the potential to cause a fire as they work by burning through materials. It is advisable therefore to always be with your machine when engraving or cutting and have a fire extinguisher to hand. There's a different bed that replaces your 3D printing print surface with removable supports to sit your workpieces on, and the machine won't run unless it sees the correct QR codes from the laser bed in place, so there's no chance of accidentally cutting through your PEI bed. The laser version also comes with an air assist pump, which blows compressed air onto the spot where the laser hits your material and helps with blowing away any burnt material, which makes the laser more efficient. Unfortunately, the downsides to any laser engraver or cutter is that smoke is produced when it's used. The H2D has an extractor vent, but when you use a laser, you'll need to attach a duct and a hose to carry the extracted smoke either outside or to an air purifier. Only testing will show how well the H2D can remove smoke and fumes, but there's no escaping the fact that there will be some mess that will build up inside the machine's enclosure while using the laser. To avoid this build-up of material from affecting the operation of your H2D, you will have to undertake regular cleaning, possibly after each job. It's this potential mess that is making a lot of people question why Bambu Lab have chosen to combine a 3D printer with a laser engraver. As I say, only testing will really tell how good a job they've done. There is also a blade cutting attachment that clips onto the same place as the laser, and there is a cutting mat bed that goes with it. The cutting mats are sticky and hold sheet materials still while you cut them. I have another machine that has this same function, Xtool's M1 Ultra, and the blade cutting function is my favourite thing that machine can do. With the blade tool, you can cut out things like adhesive back vinyl, stencils, and even heat transfer vinyl. Using heat transfer vinyl and a suitable iron or heat press, you can transfer your own designs onto things like clothing, so you can design and make your own merch. There are lots of other things you can do with this feature too, and the good part is that there's no cleanup to do afterwards. You just switch your bed back, remove the module, and go back to 3D printing. Pen drawing or plotting is also an option, and with this module you can basically clamp a pen to the print head and the machine will draw out any designs. You can use this in conjunction with the blade tool to make your own gift cards or other crafts. As you can see, the H2D can be a lot more than a 3D printer, and there is a lot of testing to do before I'll be able to give my opinion on how well it does everything. Make sure you hit subscribe to find out what I find, as I'll be sure to tell you about everything, good and bad. Thanks for watching, and I'll see you in the next one.